Have you ever just stopped and looked at a giant crane lifting a shipping container and wondered, how? How is that even possible? There's this incredible hidden force all around us doing some of the heaviest lifting in modern engineering, and most of the time, we don't even see it. Well, today, we're going to pull back the curtain on that hidden force.
I mean, seriously, look at an excavator. We've all seen them digging up a construction site. How in the world does that machine scoop up and just casually move tons of rock and dirt like it's nothing? What is the secret to that raw power? Or what about this? You're on an airplane that weighs hundreds of thousands of pounds. As it comes into land, that landing gear has to drop down and lock into place perfectly. Every single time. It has to be flawless. How does it do that?
Well, believe it or not, the answer to both of those questions is exactly the same. It all comes down to a brilliant concept called fluid power, and that's the hidden force we're diving into. Okay, so we've put a name to it, fluid power. Sounds cool, right? But what does it actually mean? Let's get right into it and define what we're talking about.
So at its heart, fluid power is all about using pressurized fluids to do real physical work. You know, pushing, pulling, lifting, turning. Now, you can do this with gases, which is called pneumatics, or you can do it with liquids, which is called hydraulics. And for this explainer, we are absolutely focusing on the incredible strength of hydraulics.
Now for the real magic. How do hydraulics get to be so ridiculously strong? Well, it all boils down to this one fundamental principle of physics that was figured out hundreds of years ago. It's the secret sauce. Yep, we're going all the way back to 1653 to a guy named Blaise Pascal. He figured out that if you take a fluid that can't be compressed, like oil, and you put it in a sealed container, any pressure you apply to it gets sent out equally in all directions without losing any of its oomph. That one idea unlocks one of the most powerful concepts in all of engineering, force multiplication.
So how does that help us? Okay, check this out. It's actually pretty simple. You apply a little bit of force on the small piston on the left. That creates pressure in the fluid. Now, thanks to Pascal's law, that exact same pressure zips through the fluid and pushes up on that much bigger piston on the right. And because the area of that second piston is so much larger, the same pressure creates a way bigger output force. It's that simple. A small push on one side creates a giant lift on the other. That's the whole trick. So what does a real hydraulic system actually look like? Well, let's break it down and meet the key players that make the whole thing work. Think of it as a team.
You know, a great way to think about it is like the human body. You've got the pump, that's the heart. You've got the actuators, those are the muscles. The control valves, they're the brain. Then you have the reservoir, which is kind of like the fluid hub, and the hydraulic fluid itself, well, that's the lifeblood flowing through it all. Let's take a quick look at what each part does. All right, first up, the pump. This is the heart of the whole system. It's usually hooked up to an engine or an electric motor, and its whole job is to take that mechanical energy and turn it into hydraulic power by getting that fluid moving under pressure. Simple as that. No pump, no power. Next up, we've got the actuators. These are the muscles. They're the ones that take all that energy from the pressurized fluid and turn it back into useful work. That might be a cylinder that pushes and pulls in a straight line, or a motor that spins around. This is where the magic actually happens, where the work gets done. And now for the brain of the operation, the control valves. These things are the decision makers. They tell the fluid where to go, they manage how much pressure it has, and they control how fast it moves. This is what makes hydraulic systems not just powerful, but also incredibly precise. Okay, let's talk about the fluid itself. It's really easy to just dismiss it as, some kind of oil. But that hydraulic fluid is actually a super engineered liquid that does way more than just one thing. So yeah, of course, its main job is to transmit power. That's a given. But it's also a lubricant, keeping all those moving parts from grinding themselves into dust. It's a coolant, pulling heat away from the components that are working the hardest. And it even helps create seals to keep that pressure locked in tight. It's a true multitasker, the lifeblood of the whole system. And you can't just use any old fluid. They're all designed with different trade-offs. You see, your standard mineral oil is cheap and a good lubricant, but it can catch fire. Not great if you're working in a steel mill, right? So there, you'd probably use a water-based or synthetic fluid for fire resistance. Or if you're working in forestry, you'd want a biodegradable fluid to protect the environment. The job always determines the fluid. All right, we've got the theory down. Now for the fun part. Let's look at where the stuff actually shows up.
And I promise you, once you start looking for it, you will see this hidden force absolutely everywhere.
Inside factories, you've got giant hydraulic presses stamping out car doors with unbelievable force. Injection molding machines use hydraulics to precisely create pretty much every plastic thing we own, from our phone cases to Lego bricks. And in your own car, that effortless feeling when you turn the wheel and the solid, reliable force of your brakes, yup, that's hydraulics.
I mean, the entire world of heavy machinery basically runs on this stuff. The construction equipment building our cities, the tractors and harvesters that grow our food, even the loaders putting cargo onto airplanes, they all depend on the massive power of hydraulics to get the job done.
And it doesn't stop there. The applications get even more extreme. In an airplane, hydraulics control the landing gear, the flaps on the wings, pretty much everything that moves. They even steer rockets on their way to orbit. And on the battlefield, hydraulics give a tank the ability to swing its massive turret around with incredible speed and accuracy.
So, we've seen just how powerful and widespread hydraulics are. But like any technology, it's not perfect. So let's zoom out and look at the big picture, the pros, the cons, and the single most important thing to remember.
The upsides are obvious, right? You get a crazy amount of power and fine-tuned control from parts that are actually pretty small and tough. But there are trade-offs. They can leak, which is messy. They need constant maintenance to keep that fluid clean. And depending on the fluid, they can be a fire hazard. And this right here, brings us to the most critical point of all. Just look at that statistic. More than 3/4 of all hydraulic failures are not because a big metal part broke. They're because the fluid, the lifeblood, got contaminated. A little bit of dust, water, or tiny metal shavings in the fluid is the #1 enemy of every hydraulic system out there. So, from the brakes in your car, to the garbage truck that comes down your street, to the planes flying overhead, fluid power is this quiet, unbelievably strong force that shapes our world. Now that you know its secret, the only question is, where are you going to spot it next?